Hello, sir.
Yeah, hello, Bhavna. I'm audible.
Yes, sir.
In the last class, we discussed about the resultant vector. Is it any doubt in that concept? The resultant vector.
No, sir.
Alright, so I told you to go through the triangles law of vector addition and another is parallelogram law of vector addition. Have you done that?
No, sir.
No problem. Let's take this up. So main topic of discussion is triangles law of vector addition. Okay, great. Now we are into the vector addition. First, let's start with the basic vector addition. Vector addition. It is not similar to the scalar addition. In case of scalar, what we used to do, we say 5 plus 6 comes as 11. Here, this is not the case because there's some direction associated with it. So, assume you have a random vector like this direction, and let's say another vector is a 30-degree to this. So, this is 5 magnitude, this is 6 magnitude, the angle is 30. If I have to add these two vectors, I can't simply do like 5 plus 6. This is the thing. If you see this 5 vector has this much length on the 6 vector. Can I say this much part of the length? Because if you see from top, what you are going to see just this part of the 5, uh, whatever the 5 and direction of the vector. So this is the top view. If I see from the side, this is the length which I am going to look for the 5. Can I see that?
Yes, sir.
So in this case, we come up with a thing which is called resolution of vector. If I resolve it, what will happen is I will have two vectors. All the vectors I will be having in a 90-degree scale. And we know how to solve for 90 degree. You can take one as I direction, one as J direction, and keep it, right? So this is what I will be happening. If I resolve this vector, the 5 will become, let's say the 5, this is theta, so I can say that this direction, the projection of 5 will become as 5 times of cos theta. Can I say this? And 6 was already there, so this thing becomes this. Okay. And here this side I don't have any component of 6, so I will say just 5 of sine theta. So let's say this is j cap, this is I cap, so you can finally write it. The resultant vector comes out as 5 sine of 30 degree times of I cap plus for j, no, this is for the j cap basically. For the I cap you have 5 of cos 30 degree plus 6. Okay. This is the thing. This should be I just right. It's not so. So that's the thing. Okay. This is how we are supposed to do the vectors. Like basically the
Abacus,
vector.
sir.
Although we have not studied the component part till now, so we can skip this for now. Okay. So let's do one more thing. Let's go with the proper of the vector addition. In this, we will learn what are the ways in which I can have some addition of two different given vectors. So, what are the methods? In a graphically, if I have to add two vectors, we have to, that any vector is represented in the form of arrow and lines, right? So, keep the vectors such that, like, if any two random vectors are placed in a random graph, okay, in this way, what we have to do, if I keep this vector Like this, it won't make any difference because still the magnitude is same and what is that? Magnitude and that is same. Direction is same, right? I have just changed its position from here to here. Like whatever I do, it won't make any difference. It is here, right? Can I see this? This is the second step of doing. Okay, what you have to do, if you have two vectors, any vector, okay, join. You have an option. You can also do for this also. That take this vector, join tail of this vector to the head of this vector. Either you can do is join this
Okay.
tail of this vector to head of this vector. Okay? This is what you have to do. These vectors can be
Oh,
anything. It can be like this in also in the plane. Okay, you can assume that thing. It can be like this also. It can be like that, like, and in any shape it can have this. This is in the vector position. So to keep the vector addition, what we need to do, we need to put it like this. Okay, join head and tails. So let's say I join. This is the tail. This is the head. Without changing the real orientation of the vector. This is the main important part. You don't have to change orientation, or you can say the direction. Okay.
okay, sir.
Now what will happen is, you will be having a vector in a separate form. So, like, okay, this is the angle case. I will discuss special cases. Special cases first. Okay. So, what are the special cases? I told as simple as that. First case is if you have two vectors kept like this. Okay, let's say these are two different vectors. Two different vectors. First case is this: A vector, B vector. If they are in same direction, I told you what you can do is, if you see carefully, isn't it like if I keep it like this? So what will happen is, if because the direction is same, right? If they have same direction, so can I say the A plus B vector is giving me nothing but the total length plus this direction? So can I say whatever the direction A or B have, I will just add them individual magnitude because unit who is going to represent the direction, unit vector and unit vector for a parallel vector is same. So I can say that whatever the unit vector, let's say a magnitude, a is a unit vector, and what will be here? A magnitude plus b magnitude. This is the resultant I'm going to get. Can I say this for the
Yes,
total?
sir.
And what is this? This is nothing but, if okay, if you just take a this side, so you can write this as a plus here you have b, and we know that b and unit vector a unit vector is same, so you can write it like this. So what you have got? A vector plus b vector. Okay? This is how we can represent this thing by a vector plus b vector. Clear?
Okay, sir.
Okay, this is something. Another is, again, if they are anti-parallel. In case of anti-parallel, you can simply do it like this is one direction, this is another direction. Let's say another vector is this one. Now, how I should do? You know, I have to put it like this. Is it like maybe a vector is placed here? So what you can simply do is put like this. Okay, understood? So
Okay, sir.
let's say this is the point. This is the five in I direction. Okay, and this is maybe minus 4. Can I say this? Because this is the previous direction. So,
Yeah.
no, actually, this is the thing. And you know how to add two vectors if they are in the coaxial line, right? Okay. So, assume if I say that a magnitude can never be positive, negative, right? If like here, what happens is this, well, this terms comes out due to the minus 4 into I, this thing, right? This thing, it comes out like this. What if I remove this negative? So you know the direction will become this, right?
Yes, sir.
But magnitude, I have, because I have removed negative from here, I will keep negative outside. So can I say you can assume a vector in this direction having a distance from this point, the distance is minus 4. Can I say this? Look, we generally measure the distance from this particular point, right? And it is in this
Yeah.
direction. So when I say it is going 4, it means it is not in this direction because the here from
It
this
is
particular.
not minus for it, sir.
Yeah, actually, look, if you write this as minus 4, no, what will happen in Cartesian, as per the Cartesian plane configuration, from this particular point, this side you will never get minus 4. The minus 4 will be always lying at this point, okay?
Yeah.
So even if you represent like this, that okay, I had minus 4I, like okay, so this minus 4 representing the exact value of that particular point. So no, this is not the particular point. Okay, the real case here it is that minus 4 particular point. Okay, so basically what's the main crux of the problem here is you have to add both of the vector. So when you add both of the vector, what you're going to get is a vector plus b vector. Okay, and you know the b has it opposite direction, so you make it minus. So what you have got at the end of the day, a minus b vector. Clear? This
Yeah,
is the result
obviously.
because they are anti-parallel in the nature. Okay. Is that clear?
Obviously.
Okay, fine then. Mm, okay, that's fine. And now we can look for something else. Okay. Again, the same way we are going to do. Assume now the third point from here after we move to the triangles or vector. I told you if any two random vectors are placed in a plane, join head and tail. Take tail of it, join it like this. Okay. So from here we have to discuss the third case. Okay, if this is the case, the resultant is supposed to be coming out like this. We yet don't know the value of this resultant, so okay, look. From here after you must have got to know that the resultant comes out nothing but the remaining part, right? What are the remaining tail, remaining head? Is it? The same goes here also. What is the remaining head you have, remaining tail you have? You can simply say that I have uh, yeah, I have this tail remaining, this head remaining. If I join these two, I will get the resultant vector. Can I say this?
Yes, sir.
Okay, so that's the thing. So here's how you have a resultant. Okay, and, this is A, this is B. Okay, that's the thing. We have already discussed this thing. Now come to the triangle's law of vector.
But we have to place the resultant vector in the same direction, like how we have placed it.
Huh, okay, you can't do like this. Basically, you have to join head to head, tail to tail. Yeah, that's
Yeah,
yeah. Basically, third resultant should be like if this is the tail, so tail should be joined with this tail. If head should be joined with the head itself. Okay,
obviously.
so that's the thing. Acha. Okay, wait. So here you know that by the whatever we have discussed till now, you know this resultant is equals to a plus b. Is it
Yes, sir.
right? If you see, if I just take this r to that side, what it will become? This plus r vector. Can I minus r vector? Can I say this equals to 0?
Yes, sir.
If you say, if I take the random, what does this looks like? Isn't it looking like you have one vector a like this? Okay, another vector is this. Okay, you know what is the r right now? R is nothing but this. So what is the minus r I am adding over? I am adding this, like r was this, right? So what is minus r? The minus r will become this. Can I say this?
Yes, sir.
This is the minus r. If I replace this minus r with another vector c, can I say minus r is equal to some c vector? So can I say that a plus b plus c is equals to 0
Yeah.
when they are coming into 0, when they make a cycle. Clear? When your vectors make up a cycle, it's not necessary for only two vectors. If let's say 100 vectors are there, this, 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 this. If they make a proper cycle, the net resultant of this vector come out is 0. Clear?
Yes, sir.
Okay, so that's the thing. Triangle of vector addition. Although the thing is, whatever they have to tell in the triangles law of vector addition, we have already done more than that part till now by ourselves. Okay. Okay. So what does the triangles law of vector addition say? Is that if two sides, if two vectors A and B represent the two sides of triangle, two sides of triangle. Then the third side will be represented as uh, resultant vector. Clear? Of the triangle. Okay, or you can say then the third side will be represented, or you can then their resultant is represented by the third side of vector, like third side of triangle.
Okay, sir.
So again the same thing. Okay, it doesn't says very different give any equation to us. It simply says that if you have two things like this, one vector, okay, one vector, I can say it looks like I can form a triangle out of it. Okay, so you can say this is one side, this is second side, and you know what is the resultant. If resultant is always summation of these two, so what is the resultant? Resultant, it's represented by the third side of triangle. That's, you can see it forms a triangle, right? Same thing we used to do earlier. One side, another second side, and this is third side of triangle. Okay. Main thing is a parallelogram vector of vector. Parallelogram law of vector says that if two vectors are represented like in a magnitude and direction by two adjacent side of triangle. Okay, keep remember adjacent side of triangle. Okay, then the resultant is represented by the diagonal of parallelogram. So parallelogram law of vector addition. Here what needed? Two consecutive sides. Consecutive means to say you start one side with a vector and the moment it ends, start another side with another vector. Okay, understood? Then the third side representing the start and the end will be the resultant. Here what happens is it says I don't need two consecutive moving. I need two adjacent. What is adjacent? Adjacent is this. Okay? If I make a parallelogram, this is one side and I need adjacent side. Adjacent means I can make it like this. Clear? Then third side will be like what is the resultant of these two vectors? If I say these are two vectors. Okay, so the resultant will be the diagonal of these two vectors. So may assume the diagonal might be something here. So this is what you are going to get as a third side. If you anyhow if you want to complete it, it will look like this. Okay, Bhavana, is this clear?
Yes, sir.
Okay, so this is a parallelogram law of iteration where the resultant comes out as a plus b. By definition, if two sides of a vector, if two vectors represent two adjacent sides, and then the third side is represented by the diagonal between them. That's the thing for now. I hope it's clear. This and this is a complete parallelogram. Okay. Um, This is parallel to this. Okay, double dash, double dash. That's mean to say they are similar. This and that's not similar. This is similar. Clear? They are parallel. They are parallel to each other. Any doubt here?
No, sir.
No, right. And you can simply R is already written over here. Now what happens is, if I add more than two vectors, what I'm going to like till now whatever we did, it was just for a two vector. I was getting a third vector as a resultant. Okay. So how I should represent more than two vectors? Addition of more than two vectors. Or assume I just gave you two vectors by now. Let's say you have four vectors. No, let's say three vectors in the situation here. One, two, maybe three over here. Okay, and maybe okay. Let's say three vectors. Here. You know what is my first step to solve? First step, align themselves head to tail. Right. I will take this vector, put
Yes.
it. Okay. I will come with another vector. I will say, get me the head and tail. So you can see I have got two vectors. So if you see, I know one thing. Somehow vector addition. I have to add, right? It means I have to do a plus b plus c, right?
Yes.
So can I do that? Let's. I will add this after that. First, cover this a plus b. I know one thing. What is a plus b? This is a vector. This is b vector. So what is a plus b? You know that a plus b is nothing but the resultant of the small
R
resultant.
vector.
So this will be basically the resultant of AB. Okay, I'll write resultant of AB.
Yeah.
So
Okay.
can I do one thing? Remove it from here. What I have got? Let's keep it here. Try. Net resultant I have to calculate. That will be A vector plus B vector plus C vector. Okay. What you have got here? That is resultant of AB plus C vector. Now what is the third vector? Can I say if I remove, I can directly work with this vector. I don't need to know about these two another vector A and B in this picture. Can I say this? So I will just take another vector parallel to the this, okay, because I have to make a different picture. You can say this is a R vector, similar to R vector maybe. Might be this. It looks very similar to R vector. So can I say that I don't need now A and B because I have got the resultant of those two? Is it? Now I will go to the C vector. This is my C vector. Bring this into the picture. If I bring that into my picture, what I'm going to get is, you can see C was looking like this. So again, the same method. We had to join the head and tail. So what I have got, this was R A B. This was C vector. So you can see that. Now what is the left? Tail to head. This is the final resultant. Okay. So this is the resultant of E because this is AB. This is C. So I can say this is the resultant of ABC. What is the resultant of ABC?
A bar
A.
plus B bar plus C bar.
Yeah. So that's the thing, and so on. You can do for n number of vectors, whatever is given to you. Clear?
Okay, sir.
Like, basically, you will try to figure out a cycle out of it, but it should not make a cycle. Okay, there should like
Okay, sir.
it will be turning like this, but there will be a point that there will be a break of the cycle because here, if it completes a cycle, you know the resultant will always come out zero.
Yeah.
But it should not be like that. Okay, the moment it turns back from here, you can say this is the resultant of the whole till now whatever the cycle we have got here, resultant of this whole cycle is this much. Clear?
Okay, sir.
So let's say another four vector I'll take this last one, then after that I'll move to the new page. Okay, let's do it here itself. No need to make okay, this is one vector pointing to some point maybe. You can see like this, okay? A very simple idea. Go with each of the vector. How it will its alignment will look like. Take it, place it. This is okay. Similarity. That's why I said this can be converted into directly. Another is okay. Let's take this vector. Maybe I can keep it like this. Okay, head to head. I go with this vector and I will keep it like this. Should I keep it like this? I have to done this. Now the last vector. Where I should keep it like this, it becomes different image. Okay, if I join, okay, this already joined. Yeah, I can make it like this, right? Understood. I can make it like this. Got the idea?
Yes, sir.
So what is the final head and tail position? We can see this is the final left. So this is my resultant going to clear here to here.
Oh,
You can see. Uh, Look till here you are getting a cycle. The moment you reach here, the cycle has been broken. Okay, because from here
okay,
the
sir.
length goes like this. So this is the resultant. If it could continue till this point, what will happen? The resultant of this whole thing comes out as zero. Okay. So look, every time you won't be given the graph and all like lot of like you will won't be given 10 vectors in the plane because in that case you will have to identify right from where you should start, what should be the next vector to make a proper alignment. Okay. This will not be the case always. You will be given the equations to solve, not these kind of vectors to solve. Like okay, how you can align this
Okay,
and
sir.
this. What will happen is assume you are given some figures. Okay, so you have to figure out how I can align my vectors to solve my problem. Okay, that we are going to do now as an analytical method for the prediction. And on the new page, Bhavna, should I start the analytical method because 3 minutes are left and I think the topic will take nearly 10 to 20 minutes. I have to take another class also.
So it's best like if we take it in another class
If we take it in the class, okay. So wait.
because I have to again go to my college right now and it's at 6.
Okay, fine, fine. Okay, then we can. Okay, I didn't have new topic to start then now. Can we end by here?
Yes, sir.
Because yeah, the new topic will take time. All
Yes, sir.
right, Bhavna. So by this we can end here. I will share some PPT, like one problem sheet today. Okay,
Okay, sir.
you can start solving starting questions because it contains a lot of problems in that. Don't solve this just from the starting
Okay,
part.
sir.
All right.
Okay, sir.